So this is really just a question about memorizing how exponents work. When we have both fractional exponents and radicals involved in something, this is really no math at all, really just vocab or memorization. So we need to understand that if we're taking the square root, or in this case, a seventh root of a number that has some exponents, that we can express that as a fractional exponent, where the number on top is the number, let's just focus on the x here. The number on top is the exponent that was on the number or on the variable, and the bottom part of the fraction, the denominator, is the root. So this would be x to the 9/7 if we were taking the seventh root of x to the 9th. Those are the same, and so we can kind of see that b is going to do that because it's going to apply to the y as well, and then the parentheses let us just kind of apply everything. So that's it. That would be the whole question. This is a 10-second question. If you know this rule, there's really no debate here. However, just to kind of make it a little clearer what the rule is, I think the better way to think of it is the reverse way. So the way that was explained to me is that if I have something like x to the a over b, that becomes the b root of x to the a, right? So this is kind of, if I gave you choice B in this question, then it might be easier to turn it into the original thing that we've got. And that's okay, right? This is a kind of a multiple choice question, so we can always work backwards if we're not quite sure how to work forwards. So x to the a over b is equal to the b root of x to the a. That is the rule. That is something you need to memorize and be comfortable with. The most common example of this is if I have something like x to the 1/2, you've probably learned that x to the 1/2 is the same as the square root of x. Well, why? Where did the 1 and the 2 go, right? I mean, there's a b and an a, there's a 9 and a 7. What's going on here that those numbers disappear? Well, for x to the 1/2, both the 1 and the 2 are numbers that just by convention we don't write when we write algebra, right? So every number or every variable has an exponent of 1, but we don't write the 1. It's there if we want it, but it's not written. And so here's a good example of that, right? The x has an exponent of 1 from the 1/2, but we wouldn't write it now because it's just a 1, and so we don't write those. Also, for whatever reason, square roots, we don't write the 2 that kind of goes with every other type of root, right? If it was a cubed root, we would write the number, but for whatever reason, square roots, we just leave out the 2, but it's kind of there. So just to give you one last example that is a little bit more understandable, if I had x to the 2/3, now I would see both of those numbers appear, right? That's the cubed root of x squared. The cubed root of x squared, right? So the bottom of the fraction became the root, the top of the fraction stayed as kind of like an exponent. And the way to remember this is that let's do a different color here. The roots of a tree are on the bottom of the tree, right? So the roots of a tree are on the bottom of a tree. The root of the fractional exponent is on the bottom of the fraction, right? Bottom of the tree, bottom of the fraction. Hopefully that gives you something to work with, but that's really all there is to this. It looks worse than it is, but for those of you who had this rule memorized, this was a very, very easy question. It literally took you 10 seconds, and that's what we want. This is supposed to be a hard one. So if we can get a late section question right confidently in just a few seconds, that's really good for our score. And so some of them will be kind of tricky questions or time-consuming questions, but some of them will just be about obscure rules that we just need to memorize. So those are things that were fully within your control to memorize between now and test day. So try to study those things and add those points to your score.